Yeah.
Okay, position of a particle at time t is greater than or equal to 0 is given by this. Boom, position. Love it. T squared minus 2 for our horizontal position, 2/3 t cubed for our vertical position. Interesting, interesting, interesting. And our first question is find the magnitude of the velocity vector at t equals 2. Oh, magnitude of velocity vector at t equals 2. So, magnitude of velocity vector at t equals 2, I need to find the velocity vector first. Easy. I need to plug in 2. Easier. Then I need to find the magnitude by using the Pythagorean equation. Kind of a pain, but doable. So first of all, I'm going to find x prime of t, aka dx dt. That's my horizontal velocity. That's 2t. My vertical velocity is given by 2t squared. Great. So my velocity vector is actually 2t comma 2t squared. This gives me a formula for my velocity at any time t greater than or equal to 0. But I don't want it at any time t. I want it at 2. So I'm going to plug in 2 and get my velocity at t equals 2, which should equal 4 comma 8. Means I'm moving to the right at a rate of 4 something per something and upward at a rate of 8 something per something. I wasn't given units, so I don't actually really know, but that's fine. Now, basically what that means is at this point, I've got, boom, horizontal velocity 4, I've got, whoop, vertical velocity 8. So what is the magnitude of that vector? It should be the square root of 16 plus 64, which is the square root of 64, 70, 80, something like 80. If I wanted to be a really fancy pants, I could say that's the square root of 4 times the square root of 20, which is the square root of 4 times the square root of 4 times the square root of 5. 5 times 4, 20 times 4. Yes, which is 4 root 5. So that is the magnitude of the velocity vector, 4 square root 5, aka speed. That's the speed. Great, that's the speed because that is the same as the magnitude of the velocity vector. That's how quickly I'm traveling, 4 in this direction, 8 in this direction, so overall, square root 80 in that direction. Great. Then it says, set up an integral expression to find the total distance traveled by the particle from t equals 0 to t equals 4. Total distance traveled. Total distance traveled is I shouldn't have raised that. Oh well. Is simply speed times time. Added up gets total distance. So integral expression for total distance traveled should be the integral from 0 to 4 of my speed. Remember, speed is the magnitude of the velocity vector, but in this case with variables. That is dx dt squared plus dy dt squared dt. This gives me a formula for the speed at any time t, because basically what I have is dx dt, which is 2t, and dy dt, which is 2t squared. So my speed is the square root of 2t all squared plus 2t squared all squared. So if I take all my little speeds, multiply by times, I should get total distance traveled between time 0 and 4. Fortunately, I don't actually have to find that integral, I just have to set it up. C, find dy dx as a function of x. What is it? Well, I remember that dy dx is simply given by dy dt divided by dx dt. Vertical velocity divided by horizontal velocity. Great. So in this case, I already have that. That's 2t squared divided by 2t, which is something like t Magical. However, that is not a function of x, so how do I get it to be a function of x? Well, I need to find t in terms of x, I think, and then maybe I can plug it in. That's what I'm thinking. So this is a formula for dy dx. Hooray. But it's not in terms of x. So if I want to get it in terms of x, I can remember that x is equal to t squared minus 2. So therefore, x plus 2 is equal to t squared. So therefore, x plus 2, the square root of x plus 2, is equal to absolute t. So how do I know whether this thing is positive or negative? Well, that would mean that either negative square root x plus 2 could equal t, or square root x plus 2 could equal t, right? However, t is positive. So this little fancy girl here is not going to work out. No, no. This one will, because that's positive and that's negative. Definitely positive. So a formula for my little rate of change here should be the square root of x plus 2. So these are both formulas for dy dx. One of them is a function of x. One of them is a function of t. I was asked for a function of x, so I went back to my relationship between x and t, solved for t, so that I could write it in terms of x. Cool. D, at what time t is the particle on the y-axis? And find the acceleration vector at this time. On the y-axis. I want it to be on the y-axis. On the y-axis. Meaning x of t has to equal 0, right? Yes, because if x is 0, then I'm on the y-axis. So I'm going to come up here to my horizontal position equation and say 0 needs to equal t squared minus 2. Therefore, 2 needs to equal t squared. Therefore, square root 2 needs to equal absolute value t. Therefore, square root 2 equals t, or negative square root 2 equals t. But this fancy pants right here doesn't work because I'm only dealing with positive t values. Therefore, t equals square root 2. Interesting. That is the time that the particle was on the y-axis, because that's the time when my horizontal position is 0. Now I need to find the acceleration vector at that time. Well, first of all, I better find my acceleration. Here's my velocity vector. So my acceleration vector, d2x dt squared, should be 2. And my vertical acceleration should be 4t. So my acceleration vector in general is 2, 4t. That's my acceleration vector. Constant horizontal acceleration, non-constant but linear vertical acceleration. If I want to find it at square root 2, I will plug in square root 2 at t equals root 2. Nothing happens to 2, but 4t becomes 4 square root 2. So that is my acceleration vector at the time when the particle was on the x-axis. And that's the end of the problem. Hooray.